I'm Doug Fern, and this is my take on music recording. Changing the speed of a tape machine while recording was a common technique in the 1960s and 70s. This was used in a variety of situations, the most common of which was on vocal tracks. Here is how it worked. The tape was slowed down slightly from its standard speed of 15 inches per second while recording the vocal. On playback, the speed was restored to normal. The effect was a change in the character of the singer's voice. Why would you want to do that? Well, during that period of recording history, it was often believed to be desirable to have young-sounding singers. The speed change made the singer's voice sound more youthful and exciting than his or her natural singing voice. This was presumed to make the song more appealing. It had the additional benefit of making it slightly easier for the singer to hit notes at the upper limit of their range. The tape speed was changed by less than 2% for this effect. The sound of the voice remained believably natural, but if you reduced the tape speed too much, the vocal started to sound fake. You could get away with greater speed change on background vocals, but there is a point where the voices start to sound comical. An example of this is on the original Apple Records single of James Taylor's Carolina in My Mind. The background vocals sound almost like a cartoon. In addition, I suspect the entire recording is slightly sped up. The Beatles used variable speed extensively on their vocals and background vocals, and even on some instruments. With the change to digital recording, we have largely lost the ability to use variable speed recording. Digital does not lend itself to changing the recording speed. It tends to be glitchy, and there is a loss in quality. Tape handled the slight speed change with no problems at all. Here's how it was done with traditional tape machines back then. A tape machine relies on a capstan and pressure roller to meter the tape as it passes by the recording and playback heads of the transport. In machines from the 1950s through the 70s, the capstan was the metal shaft of a special motor that rotated at a constant speed. The speed of the capstan motor was controlled by the AC mains frequency, which is 60 Hz in the Americas and 50 Hz in most of the rest of the world. You might think that the AC line frequency would not be very stable. After all, the line voltage varies quite a bit over seconds and hours and days. At my studio, out in the country, the line voltage has been as low as 90 volts and as high as 133 volts. Most places have a more narrow voltage range, but you get the idea. It all depends on the combined load at any given instant. The same is not true of the line frequency. Our electrical distribution system relies on the interconnection of dozens or even hundreds of individual power plants, and it is imperative that they all be precisely synchronized. Any variation in the frequency would cause immediate and perhaps catastrophic consequences. So power plants can only deviate by a tiny fraction of a hertz, and corrections have to be made nearly instantaneously. This provides a reasonably stable frequency reference for the motors designed to lock on to the line frequency. This type of motor, called a synchronous motor, does not have many applications outside of old tape machines and other industrial motors that have to maintain a precise speed, and in clocks that plug into an AC outlet. A clock can run for years and maintain its accuracy within a few seconds when it is locked to the 50 or 60 Hz line frequency. If we want to change the speed of the capstan motor, and consequently the speed of the tape, we can provide the motor with a variable frequency near the 50 or 60 Hz standard. This can be done with a sine wave audio oscillator driving a power amplifier, which then drives the capstan motor. In my studio, I had a Hewlett-Packard audio oscillator that went from 5 Hz to 200 kHz. It was very stable and accurate, and produced a very pure sine wave. It was built in the 1950s and used vacuum tubes. I still have it, and it still works great. The HP oscillator had a large metal dial on the frequency control knob, engraved with precise markings indicating the frequency. If the oscillator was set to 60 Hz, the capstan motor ran at exactly the normal speed, but by adjusting the frequency slightly, the tape could be slowed down or sped up. The amount of change needed is small. In most variable speed applications, the frequency was rarely set below 58 Hz or above 62 Hz. That was plenty for most recording requirements. That's about 3% above and 3% below the standard speed, which means the pitch and tempo of the song could change by that plus or minus 3%. Not a dramatic change, it would seem, but it could have profound effect on the sound of an instrument or voice. When recording an off-speed track, the actual oscillator frequency was noted on the track sheet in case a punch-in was required later. Now that you know about this, you might find it interesting to listen to many of the pop records from that era and see if you can hear the effect. Once you learn what it sounds like, you will probably spot it on many records. It was part of the sound of that era. But like any effect, it is easy to go too far. Once you reach that point, the vocal performance started to lack credibility. It was sort of the audio equivalent of the uncanny valley effect in digitally created humans in video. It initially looks convincing, but it just doesn't feel right. You could take the variable speed effect to an extreme for an effect. Les Paul used this extensively in his pop records with Mary Ford in the 1950s. You can hear guitar solos that have more notes than anyone could ever play. Les Paul did not do that with variable speed as I described it, but by switching his Ampex 8-track machine from 15 inches per second to 7.5. That was half the speed and an octave lower, allowing him plenty of time to play all the notes. He had to play them in as low a register as the guitar would allow, so that when played back at normal speed, the guitar didn't sound too much like a mandolin. It was a unique sound he invented, as he did with so many other early multi-track recording techniques. An extreme example of variable speed recording is in the Chipmunks recordings. Those classic novelty tunes work because the singing voices are so far from human that we believe that it is actually tiny chipmunks singing. Great for a novelty, but too unserious for most music. There were other applications for this technique, and I used them all the time back in the tape days. Often on recordings I was producing, we did not have access to the instruments that would have been perfect for a song. For example, the song might benefit from a cello part, but all I had in the studio were double bass and violin players. I could slow the playback down and have the bass player play a part that when brought up to normal speed sounded more like a cello. Half speed would not sound good in most cases, but something shifted down several note intervals could create a convincing cello part. In the same way, a violin could be pitched down to emulate a viola part. If I wanted a tuba part, I could have a euphonium player play the track sped up, not down. Challenging for the player, but the result was a credible tuba-like sound. This not only completed the arrangement, but it created a sound that was not what people were used to hearing. If that sound was appropriate for the song, it solved a problem, as well as giving me a sound that did not exist in nature, but was still perfectly musical, with all the idiosyncrasies and creativity of a real musician. I sometimes had guitar players overdub a part with the tape slowed down. I never did an octave, but somewhere in between worked well. That way the guitarist could easily play a complex part with plenty of time. Of course, the changed speed had to result in pitch changes that landed on actual notes. especially for a fixed-tuned instrument like a piano. Converting semitones to their oscillator frequency equivalent was not something I could do in my head, so I made a chart that showed half steps up and down the scale and their proper frequency settings for the oscillator. I also used it on steel drums that were tuned to a different key than the song I was recording. It was tricky, however, to set those frequencies with precision, especially since the markings on the dial were in 5 Hz steps. So there was some time required to work with the musician to get the track precisely in tune with his instrument. That was less of an issue with fretless instruments, since good string players could easily adapt a non-standard interval, but I tried to make it as close as I could for their comfort. If I needed a unique sound for a recording, I could use tape variable speed to significantly change the sound of instruments. A piano, for example, sped up by 50%, becomes a totally different instrument. It did not sound like anything else. I used variable speed on drums, marimbas, a B3 organ, electric and acoustic guitars, various percussion instruments, and even sound effects. It was fun to do and could be very effective if used carefully. Musicians generally like to participate in those experiments, and the producer of the session was usually pleased with the results. Another variable speed application was useful when a song was not recorded in standard tuning. In the days before the ubiquitous clip-on guitar tuners, players would usually tune up to a reference note from a piano. If there was not a piano in the studio, everyone might tune to some other instrument in the room. The instruments would all be in tune with each other, but the actual absolute tuning could be off. This was not a problem most of the time, although it might be obvious when the song was played on the radio or in a club before or after a song in standard tuning. The pitch mismatch might be obviously jarring, especially if the two songs were played in a segue and the songs slightly overlapped. But what if you later decided to overdub a piano or other keyboard instrument that could not be retuned? Variable speed to the rescue. You simply adjusted the tape speed until the track was in tune with the piano. As tape machine technology advanced, the synchronous capstan motor was replaced with electronically controlled motors. That was an improvement because, as precise as the AC mains frequency was, the crystal-controlled frequency of the newer motors resulted in even better speed precision. And that technology made it possible to build in the variable speed function right into the tape machine with the same precision as the standard tape speeds. The first machine I had with built-in variable speed was a 3M M79 24-track. It was much simpler to just turn a knob on the machine to change the speed. The problem was there were no markings to tell you where you were, but an aftermarket accessory provided a digital numeric readout that made the process super simple and easy to recall a setting if needed later. The readout could be switched between its 60 Hz reference equivalent, percent of change, or cents of variation from standard. The cents function, that is hundredths of a half step, made tuning the track with precision easy. But I still preferred to use a 60 Hz reference since I knew exactly how to get the effect I was going for. It was not uncommon in those days to change the pitch and tempo slightly during the mixing session or after the final mix was completed. This was often done during the lacquer mastering stage of making vinyl records. Ideally, you could pick the proper tempo in the studio before any recording began, but the after-the-effect approach had the additional benefit of adding a sense of excitement to the sound of the recording. Of course, it also made records in non-standard pitch, which bothered me, but I never heard anyone complain about it. The use of variable speed pretty much disappeared as digital recording replaced tape machines. Digital recording does not lend itself to those easy speed changes possible with tape, at least not without some unacceptable glitchiness. The first really usable digital recorder I had was a Radar 24 system. It was designed to be as close to a tape machine as possible, but in the digital realm. It had the standard tape transport controls, and arming tracks to record was the same as on a multi-track tape machine. And the Radar had variable speed. It wasn't entirely glitch-free, but it sounded okay if you kept within the 2% speed offset that was most useful. A built-in display showed the amount of speed change in percent. I didn't have a need to use variable speed much during the time I had the Radar system, but it did give me a creative tool that was useful on occasion. Some DAWs offer this effect, usually called vari-speed. Whether the results sound like actual tape speed change is debatable, but when used within that narrow 2 to 3% range that is most useful, it might be acceptable. You have to try it and see. Note that on some DAWs, you have the option to change tempo with vari-speed, but retain the same pitch. That's great for things like speeding up a podcast or video, where the minor glitches are acceptable. But in the variable speed technique I am describing, you want the change in timbre, but not a change in pitch or tempo. Except for the Radar system, I have not tried variable speed in the digital realm. I know Reaper can do it, and I use Reaper for certain things that my usual DAW, Pyramix, cannot do. The next time I have a need for variable speed, I could create a mix in Pyramix and import the stereo mix into Reaper, overdub the part I needed variable speed on, and then import that newly recorded track back into Pyramix. You will have to determine the exact workflow that will work with your software. Despite the added complications, that way of using variable speed might be useful to me, and it might be useful to you as well. I think the effect can be very compelling in many recording situations, and I urge you to consider it. Let me know how it works. Thanks for listening, subscribing, and commenting. I can be reached at dwfern@dwfern.com. This is my take on music recording. I'm Doug Fern. See you next time.